Okay, this is part 2 of the final review. Some people saw this in class, but I just wanted to make sure everyone saw the setup for these. The first question is asking us to complete the square. I'm going to subtract 9 on both sides of my equation. N squared minus 8n is equal to negative 14. I want to be able to write the quadratic as a perfect square. So I'm going to divide b, the number in front of the linear term here. So in our case, negative 8 divided by 2, and then I'm going to square that. Negative 4 squared, I get 16. So I'm adding 16 on both sides of the equation. N squared minus 8n plus 16 is equal to 2. I can rewrite n squared minus 8n plus 16 as n minus 4 squared, and that's equal to 2. Now, to undo squaring here, I'm going to take the square root of both sides of the equation, remembering that the square root can be a positive or negative. So for instance, the square root of 9 is equal to 3 and negative 3, so a lot of times we'll write it like square root of 9 is equal to plus or minus 3. At this point, this is going to be n minus 4 is equal to plus or minus the square root of 2, which I want to see this in the final form as n equals 4 plus or minus the square root of 2. For numbers 2, 3, and 4, they're asking us to find the discriminant. So the discriminant is b squared minus 4ac from the ax squared plus bx plus c equal to 0. So looking at a standard, sorry, I'm just going to go to a different room where my dog's not crying. Looking at the standard form here of the quadratic, ax squared plus bx plus c equals 0. A mistake that sometimes people make is not setting the equation equal to 0. So in my example here, I should add 3 on both sides of the equation to get negative a squared plus 4a minus 4 equals 0. A is going to be equal to negative 1. B is going to be equal to 4. And C is going to be equal to negative 4. I just want to show this. The variable here for x can be replaced with a, b, n. We're still talking about a quadratic, and we see that the largest exponent, the degree, is 2. So this is 4 squared minus 4 times negative 1 times negative 4. So 16. I think of these like a positive 4, and then times negative 4 is minus 16 to get 0. Now the next part is asking us to state the number and the type of solutions. So we didn't talk about complex numbers, so my options are 2 real solutions, 1 real solution, and then 0 real solutions. Because I get 0, there's only 1 real solution. In this next one here, I'm going to subtract 6 on both sides. Negative 2m squared plus 5m plus 7 is equal to 0. A equals negative 2, b equals 5, c equals 7. 5 squared minus 4 times negative 2 times 7. So 25, this is going to be a positive 8 times 7. So it's plus 56. So this is 81. When it's a positive number, it doesn't matter if it's a large positive number or a small positive number. Could be a decimal, could be, 10 million. This is going to be 2 real solutions. And then for number 4, I'm going to add 5 on both sides. I want to make sure that I'm setting these equal to 0. Negative 10r squared plus 10r minus 4 equals 0. A is equal to negative 10. b is equal to 10, and c is equal to negative 4. So this looks like 10 squared minus 4, sorry, it should be 10, times negative 10 times negative 4. So 100. This is going to be a positive 40 times 4 is a negative 160. I get a negative 60. So there are 0 real solutions. All right, so those were the questions asking about the discriminant. Remember, it's just the b squared minus 4ac. That's going to come from what's inside the radical in our quadratic formula. I'm going to give you guys the quadratic formula on the test, so you don't have to worry about like having this written down already. But it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, just like with the examples with the discriminant, I need to make sure that my equation is set equal to 0. A is equal to 1, B is equal to 7, C is equal to 12. So this looks like, now some people say negative B. I think of it like opposite B, so when B is positive, I know that this is going to end up like a negative 7. If this was a negative 7 to start, and it was, some people say negative, negative. I kind of prefer opposite, because then it tells me I should write this next as 7. But in our case right now, it's opposite 7 plus or minus the square root of 7 squared minus 4 times 1 times 12 all over 2 times 1. This looks like negative 7 plus or minus the square root of 49 minus 48 all over 2. So 49 minus 48 is 1. Because I get a positive number, right? We just basically found the discriminant in here. When it's a positive number, I'm going to get 2 solutions. I can rewrite this like negative 7 plus or minus 1 over 2. Now, if this were a radical that we couldn't simplify, like the square root of 3, I'd be fine with this as an answer. But if it's negative 7 plus or minus 1 over 2, I want us to rewrite it like negative 7 plus 1 over 2. Negative 6 over 2 to get negative 3. And then negative 7 minus 1 over 2. Negative 8 over 2. Negative 4. And so those two would be my solutions. X equals negative 3 and x equals negative 4. All right, in these graphs, these are coming from a x minus h squared plus k, where h is the value, the x value to the vertex, k is the y value, and we can also think about them like the shift. So in this example, when I see minus 2, over here I see minus 2, I see minus 2 for the vertex. So it couldn't be either of these. And when I see a negative in front, if this a is positive, like greater than 0, I'm going to be concave up with my quadratic, or with my parabola. When a is less than 0, when a is negative, it's going to be concave down. So I can already say that D is not an option. And over here, I would need the vertex, right? Either the highest point or the lowest point on the graph to be at y equals negative 2. So in both these examples, they're at the negative 2. But the fact that I'm subtracting 1 tells me I should shift to the right one. In this example, they shift to the right 4. So it's going to be A. For number 7, they're asking us to find the inverse. So the first step was to rewrite f of x with y. Y equals negative 5x plus 5 over 4. Then in the way they described it in the book was interchange x equals negative 5y plus 5 divided by 4. So I'm switching where y was and where x was. This next step is to solve for y. So if it's x equals negative 5y plus 5 divided by 4, I'd multiply both sides by 4. 4x equals negative 5y, sorry, that's a 4, plus 5. Now I'm going to subtract 5 on both sides. 4x minus 5 is equal to negative 5y. And I'm going to divide by negative 5. So I would accept an answer like this. Some people don't want to have a negative in the numerator. So we could rewrite this like it's negative 4x plus 5 over 5, or sorry, 5 equals y. Or you could also write this like negative 4x over 5 plus 1 equals y. For numbers, I think it was 8 through 12, we're looking at the operations with functions. In the example here, they have 4 and 2. On the actual test, I'm not going to be multiplying them, but this would read like 4f of n plus 2g of n, where f of n is equal to 4. This is 4 times 4n plus 2 times n squared minus 2n. So this is 16n plus 2n squared minus 4n, or 2n squared plus 12n. For number 9, it says g of n is n cubed plus 4n squared. F of n is 4n minus 1. I can rewrite this like it's g of n divided by f of n. So I'm dividing the two functions. So it was n cubed plus 4n squared divided by 4n minus 1. In number 10, we're going to be subtracting. So I actually like to rewrite this one too, like g of t, and it's minus h of t. G of t is negative 3t minus 5, and I'm subtracting the 3t. I mean, there's only one term here, but if this was like plus 3 or minus 3, I think it helps to write the subtraction, and then it's like you're distributing the negative. Negative 3t minus 5 minus 3t, negative 6t minus 5. For number 11, we're subtracting again. G of t minus h of t. T squared minus 1 minus t minus 3. Or t squared minus 1 minus t plus 3. This is t squared minus t plus 2. All right, number 12. When you see this notation here, what it looks like it's almost trying to spell fog, this is f of g of x. So when we talk about functions, this is my input. The function whose name is f, when we have this input, it's going to multiply the input by 2 and then add 2 to that product. For g of x, it's taking your input, it's squaring it, and then subtracting 4 times the input. What we're going to end up doing is replacing x in my function. The input is going to be the function of g of x, the output. So we know that g of x is equal to x squared minus 4x. So this will be equal to 2 times x squared minus 4x plus 2. or 2x squared minus 8x plus 2. All right, so the next part's looking at radicals. I'm multiplying the square root of 15 times the square root of 6 and the square root of 2. So I can rewrite this like the square root of 15 times the square root of 6 plus the square root of 15 times 2. If the index, now there isn't a number in here, but when I see the radical alone, it tells me that the index is 2. We're looking at the square root. If I have the same index, then I can multiply and rewrite this like 15 times 6. But when it's the square root of 15 times 2, I'm going to rewrite this like 2 square root 15. The square root of 15 times 6 is going to be the square root of 90 plus 2 square root 15. The square root of 90 can be simplified as the square root of 9 times 10. I would rewrite that like the square root of 9 times the square root of 10, or 3 square root 10. So it's 3 square root 10 plus 2 square root 15. When we had this, I think it was the second to last test we had, people were getting mixed up about when to stop. Like they did a really great job at being able to simplify. They knew when to multiply. But a lot of people felt like they had to continue to make this into one term. It's okay if you end up with 2 different values in the radicals. That's fine. For number 14, I have the square root of 15 times the square root of 12. Now, I can write this like 15 as 5 times 3 divided by the square root of 4 times 3, or the square root of 5 times the square root of 3 divided by the square root of 4 times the square root of 3. The square root of 3 and the square root of 3 here. When we divide, we're left over with the square root of 5 divided by the square root of 4, which I'm going to rewrite as the square root of 5 divided by 2. All right, for numbers 15 and 16, if you see, like in this example, the same value in the radical and the same index, and we can add up the amounts of that radical. What I mean by that is if you had 3 square root 6 plus 7 square root 6, I can write this as 10 square root 6. But 3 square root 6 plus 7 square root 5, those, like x's and y's, I can't combine them. So in number 15, I can't simplify the square root of 2 anymore. I can rewrite the square root of 20. Now, if you're looking at the math that I'm doing here and not sure how I arrive at it, we're looking for factors that are perfect squares. I see the 4 here, so I can rewrite this like the square root of 4 times the square root of 5, or 2 square root 5. Now the square root of 20 is equal to 2 square root 5. So I'm still multiplying 2 times 2 square root 5. So 3 square root 2 plus 2 times 2 square root 5. The square root of 45 is equal to, I was looking at numbers, or the factors that multiply to 45, 1 and 45, 3 and 15, 9, or 5 and 9. So I would use 5 and 9. Square root of 9 times the square root of 5. This is 3 square root 5. And so I'm subtracting 2 times 3 square root 5. When I multiply here, this is going to be 2 times 2 square root 5. So 3 square root 2 plus 4 square root 5. And I'm taking away 6 square root 5. So for my final answer, I'm going to have 3 square root 2 minus 2 square root 5. For number 16, I can combine the negative square root 3 plus 2 square root 3. When you're looking at this one, if you're not sure, like in the same way that I'd write negative x as negative 1x, this is like a negative 1 square root 3 plus 2 square root 3. So I'm left over with a positive 1 square root 3 after add, or just the square root of 3. Now 2 square root 8, I can rewrite the square root of 8 as the square root of 4 times the square root of 2, or 2 square root 2. So this is 2 times 2 square root 2, or plus 4 square root 2. All right, that was number 16. And then the last part here, I didn't want it to be too time consuming, but I do want us to remember that when we have a radical, or in the radical form, the exponential form. So if I have x raised to the a divided by b, the a in the numerator is what I could raise this to a power, and then b in the denominator is going to be the index of the radical. I can write this two ways. I could write this like it's the radical with the b here raised to a, or I can rewrite this like x to the a over b is equal to x raised to the a to the, I guess I would describe like the bth root. The one thing to remember, and I'm going to try to show this as if I had like x, y raised to the a over b. Either of these ways are fine, but if you have like an x and a y, or in our case like a constant and a variable, if the parentheses is around both the constant and the variable, right, both the coefficient and the variable, then we need to make sure that we're raising both x and y to the a. X, y to the a, and then to take the, whatever the b root is here. Or it's x, y raised to the a. So in this example, we can write this like the fourth root of 10n raised to the fifth, or 10n raised to the fifth, then take the fourth root. When working with numbers, sometimes it's easier to take the radical first and then figure out how we could raise it to a power. So for number 17, either of those answers would be correct. And then for 18, this looks like either 7p to the fifth, and its index is 2, or 7p, the square root raised to the fifth. You don't have to write both. I'll take either one. And then for the last part here, if I'm going in the opposite direction, I'm given the radical and they want us to write this in the exponential form. When I see the exponent outside here, that's going to be the numerator to my fraction, and the index is going to be the denominator. Now please write this like 3n in parentheses to the 4/3, and 5k to the 5/2. All right, email me if you have any questions. I've gone through and tried to update all of the assignments on there. If there's any disconnect or things I missed, please feel free to reach out. Good luck, and I'll see you guys for the test.